Hello everybody. Today we will be discussing what people consider to be the most beautiful equation in mathematics. Now, if you're like most students, you probably consider this question to be very strange because to you, a math class is simply just a way of getting a credit to graduate from high school or college or whatever. It's just sort of something that's in the way, something that you don't really care about. However, I hope after seeing this equation, which I think is a great introduction to mathematics to make people more interested in higher mathematics, I hope that you at least appreciate how elegant some equations can be and how, in fact, this equation we're going to discuss in particular is actually very common when you're trying to solve, for example, a differential equation. This shows up everywhere. We're talking about oscillations. This shows up everywhere, and you'll see why that is in a moment. So what is this equation, you may ask? Well, it's the equation e to the I pi is equal to minus 1. Now, what's so remarkable about this? If you are a high school student, you would know that, for example, 2 squared is just going to equal to 2 times 2, right? Which is 4. This is very easy to understand. However, what's not so easy to understand is what happens when you raise it to a complex number, right? And what's so interesting about this is that pi has to do with the circle. E is also called the banker's number, but E has to do with compounding interest. So when you put these numbers together in this particular arrangement, you get minus 1. Let us recall, so let's just go ahead and go off on the side here. Let us recall that when you have a circle, right, it has a circumference. That circumference, let's just say the circle is of radius r, is just going to be 2 pi r. Now, what's the diameter equal to? Well, the diameter is simply just 2r. If we note here that c over d, okay, is going to equal to 2 pi r all over 2r, which is just pi, right? So this is where pi comes from. If you want to pause right now and try to figure out an explanation for why this is, go ahead. All right, so let's go ahead and get started. Let's go ahead and Taylor expand this exponential. So what I mean by that is we're going to write the exponential as a sum of polynomials. So e to the x, okay, is going to equal to the sum of 1 over n factorial times x to the n, where n goes from 0 to infinity. Now, what is this going to look like? Well, this is not as intimidating as it seems. It's just going to be, right, when you put in 0 for n, you're going to get 1, right? When you put in 1 for n, you're going to get x. When you put in 2, you're going to get x squared over 2 factorial, dot, dot, dot. Okay, now the factorial, in case you don't know, when you want to take a factorial of a number, let's just say we want to do 4 factorial, this is just going to equal to 4 times 3 times 2 times 1. It's also important to note that 0 factorial is defined as 1. Okay, another thing that we would like to note here, and this might not seem obvious why immediately, but the cosine of x can be expressed in the following way. We can write it as 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6th factorial, dot, dot, dot. I'll leave it as an exercise to the viewer to express this sum here, okay, this sum, in terms of the summation notation, right? So the sum notation. We're also going to do this for the sine here. Now again, this is not going to be immediately obvious. You can actually arrive at the Taylor series for the sine by differentiating the cosine, right? Because the derivative of the cosine is simply minus sine. The sine of x is going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial dot dot dot. We're going to take e to the I theta, okay? And we're essentially going to use this equation from up here, and we're basically just going to substitute I theta for x, okay? So we're going to have the sum now from when n is 0 to infinity, right? So we're just going to do this for a very long time, of 1 over n factorial times I theta to the nth. Okay, so as you can see, we just substituted x for I theta. So right here, we're just taking x to equal to I theta. All right. So let's go ahead and just sort of write out these terms for this equation down here. Well, this is going to be equal to, let's let n equal to 0. So we're going to have 1, right? Because n to anything raised to the 0th power is 1. Okay, and now we're going to have to raise it to the second power, to the first power rather. So we're going to have plus 1 over 1 factorial times I theta raised to the 1. Okay, and now we're going to have to add again 1 over 2 factorial times I theta squared. And now let's just go ahead and continue it down here. We're going to have to take plus 1 over 3 factorial times I theta cubed, okay? Dot, dot, dot. All right, so now we have to go ahead and write all this out now into something that looks a bit more familiar. That I is equal to the square root, is equal to the square root of minus 1. Therefore, I squared is going to equal to minus 1. I cubed is going to be equal to minus I. And then I to the 4th is just going to be 1. Okay, and that's all for. And that's pretty easy to see because I squared is going to be minus 1 since I is just a square root of minus 1. I cubed is equal to I squared times I. I to the 4th is equal to I squared times I squared, or minus 1 times minus 1, which is just 1. So let's go ahead and rewrite the sum from up here. So we know that we've just expanded it out, right? We've written it out term by term, see? So let's go ahead and just write out what each of these terms are. So the sum that we've written out, e to the I theta, is going to equal to 1 plus, well, what is I? Let me go ahead and just highlight what I'm looking at right here with a different color. What is I theta to the 1st? Well, it's just I theta, okay? Okay, now what is going to be, so now we have the second term, right? 1 over 2 factorial. Now, what is I theta to the second power? Well, it's just going to be minus 1 all times I squared. All right, and now we do this for the rest of the terms. So now we're going to go ahead and add 1 over 3 factorial times minus 1 times theta cubed minus I times theta cubed, okay? Dot, dot, dot. All right, so let's just go ahead and rewrite all of this here into something that's a bit more, digestible. So we're gonna have 1 plus I theta minus 1 over 2 factorial times theta squared minus 1 over 3 factorial times theta cubed, right? Now plus 1 over 4 factorial times theta to the 4th, all right? And now dot, dot, dot. All right, now you can just continue this sum here for larger terms, right? So you just continue writing out the sum. and you're going to get this. Now what we're going to do is we're going to go ahead and group together these terms into terms that have I and into terms that don't have I. Okay, so this is going to be equal to 1, okay, minus 1/2 factorial times theta squared. Okay, so we're going to have 1 over 4 factorial times theta to the 4th, okay, dot, dot, dot. Now these have no I. Now we have to group the terms together that actually have an I. So as you can see here, we have I theta. So we're going to just go ahead and pull out the I from all these terms. All right. So we're going to have theta, okay, minus 1 over 3 factorial times theta cubed, okay, dot, dot, dot. And if you write out more terms of this expansion, you will get that the next term is going to be plus 1 over 5 factorial times theta to the 5th, and so on and so forth. All right, so now we have reached the exciting part of the derivation. Now, let's just go ahead now and take a look. Remember how I wrote down the series expansions for the cosine and for the sine? Well, let me go ahead and just highlight those right up here. As you can see, this is what the cosine is, okay? And this is what the sine is. Now go ahead and compare those terms up here to the terms in this equation down here. Well, what do we have here? Look at this. We have 1 minus 1 over 2 factorial times some variable squared plus 1 over 4 factorial times another variable squared, right? Now, don't get frightened or confused by theta or x. I just wrote theta because, as you'll see in a moment, this theta is actually an angle. This cosine x, right? X theta doesn't matter what it is. Okay, it could be anything, right? It's just a placeholder, if you will, for what value you want to put in. So therefore, we can write out this expression, right? This exponential, okay? E to the I theta is going to equal to the cosine of theta plus I sine theta. And now this right here is truly remarkable. Now let's just go ahead and explore this equation really quickly. Okay, this is going to equal to the cosine of pi plus I sine of pi. Well, the sine of pi is just 0, so we can just get rid of that, right? And the cosine of pi is minus 1. And so therefore, we get the equation that was so sought after. E to the I pi is equal to minus 1. I would like to first just explore really quickly before we finished up this video, what exactly did we uncover here about the more general case where you take e to the I times some angle? Well, let's just go ahead and draw it out. Remember from trigonometry that when you have a point on the unit circle, okay, so this is the unit circle, right? The radius is 1. Okay, so I'll just go ahead and mark this out here as a 1. And so we have a point on the unit circle right here. Well, let's just go ahead and draw now a line from the origin to that point. Now, the angle between the x-axis and the y-axis is theta. Okay, now this is all just, trig stuff. Should be all review. Okay, so remember that the cosine of theta, what it gives you is it gives you this length down here. So the cosine of theta is just simply equal to this leg of the triangle. And now, again, let me actually just go ahead and emphasize that this is the unit circle by saying that this length here is 1. Now, this is equal to A. B is just going to be the sine of theta. Now, in the complex plane, remember, when you have some point in the complex plane, the real part is just simply how long is A, right? So let's just say we have a point in the complex plane. Let's just say that point is, I don't know. Let's just say I have this point here, A plus IB in the complex plane, which I will denote as C. So this is the imaginary axis, and this is the real axis. And this right here, right, A is the length along this axis, and B is the length along this axis. Okay, so basically, right, this is this point in the complex plane, right? We just graphed our point, all right? It's not a very good point, but we've just graphed our point now in the complex plane. Okay, so now remember that in this case here, A is simply the cosine of theta, and B is simply the sine of theta. And so therefore, when we're looking at the equation, e to the I theta, well, that's just equal to some complex number, okay? It's just equal to some number a plus ib in the complex plane, right? That lies on the unit circle in the complex plane. So just go ahead and just draw this out really fast. Okay, this is the imaginary axis, and this is going to be the real axis, right? We're just going to go ahead and draw the circle. We're going to have an angle here, okay? We'll call it theta, all right? This point here, okay, try to emphasize it as much as possible. This point right here can simply be expressed, right? This is going to be of length 1, by the way, can simply be expressed as e to the I theta. Let's just go ahead and look at the case of when pi is equal to theta. Okay. Now, we all know that theta is 180 degrees. We're going to go ahead now and just draw out the complex plane for one last time so that you see geometrically where this expression also comes from. Okay, this is the unit circle in the complex plane. Okay, and theta is equal to pi, essentially a 180-degree rotation from this point here. Okay, and where is this point? This point is -1, and that is why e to the I pi is equal to -1. If you learned something today, and if you appreciate the way that I explain things, please subscribe. I hope that the way that I explain things sort of compensates for the lack of understanding in high school, where you simply learn to pass the test and then you just forget it the next week. Please leave any problems you would like to discuss down in the comments, and I hope to see you next time.